Hey friends, it's Mrs. Walker. For our lesson today, we're going to continue talking about line plots. So our learning goal for today says, I can draw a line plot to represent data and draw conclusions about the data. Because remember, we need to be able to understand the data that's in our line plot. So the materials that you'll need for this lesson are your dry erase board. Okay, if you don't have a dry erase board, just grab a piece of paper. All right, so here's our first problem. The students in Mr. Shields' science class are growing bean plants. After 5 days, they measured the height of their bean plants in centimeters. The table shows their results. So on the left-hand side, they have the heights, and on the right-hand side, they have the number of students that had a plant at that height. Let's create a line plot to display the data. What do we need to draw? A number line, right? Then we need to draw the x's above the number line to show the data from the table. And then we need to know a number line that starts at 9 centimeters and ends at 15. Do you guys remember what we can use in our number line? So we don't have to really start, like we want to go from 0, but I don't want to do 1, 2, 3, 4, 5 all the way to 9. What can I use to show a break in my number line? Yeah, it's that double line, right? So we can use that to show a break in the number line, and we don't have to include numbers 1 through 8. So you're going to use the data in the table to draw your line plot. Don't forget to label the parts. So pause the video, draw your line plot, record your data, and then click play when you're ready to go over it together. All right, friends, pause if you need more time. All right, so here is my line plot. You ready? So notice here I have my double line to show that break. So I did not include numbers 1 through 8. We measured in centimeters. It told us that in our chart. And the x, each x will represent one student who had a bean plant at that height. The title is Bean Plant Heights. That is what I'm showing in my line plot. So friends, you want to include all of these things, your title and what you're measuring in, and the number of the key, because not everyone's going to have that chart to look at to figure out what that data is representing. So the title and the unit that you're measuring in and that key are very important to have people understand what your line plot is all about. So we're going to start at 9 centimeters. There is one person that had 9 centimeters, so they get 1x. We move to 11 centimeters. There was 4 students who had a bean plant that was 11 centimeters, so they get 4 x's. Now, friends, notice there's no 10 on our chart, so that's why I skipped over that. You still have to include that on your number line, though, to show that no students had a bean plant a height of 10 centimeters, okay? And just, you gotta pay close attention, because when I first did this, I moved my next set of x's to the 10. I wasn't even paying attention. So I was looking at it, I was like, oh, wait a minute. That wasn't in my chart. My data's not right. So I had to erase, and I had to make that correction. So make sure that you're paying close attention, more careful attention than I did the first time. All right, so let's look at 12 centimeters. There were 6 students. So 1, 2, 3, 4, 5, 6. 13 centimeters had 7 students. 1, 2, 3, 4, 5, 6, 7. Again, remember how they're lined up nice and neat. 14 had 5 students with a 14 centimeter bean plant. So we have 1, 2, 3, 4, 5. And 3 students had a 15 centimeter bean plant. So there is my line plot. Super job with that one, friends. All right, so let's use our line plots to answer questions about the data, right? Because that's the real important part of what we're going through. So this is where we're really trying to analyze the data and draw some conclusions about our data. So which bean plant height occurred most often? So I want you to pause the video, look at your line plot or mine, and find out which plant had height occurred most often. So pause the video, look for that, and then click play when you're ready to go over it together. All right, 13 centimeters had the most, the students had the most bean plants at 13 centimeters with 7. 7 students did. What is the difference between the tallest and the shortest bean plant, and how do you know? So pause the video, answer that question, and then click play when you're ready to go over it together. All right, friends, pause if you need more time. So we're really looking at the tallest and the shortest difference, or the tallest and the shortest bean plant. So that would be 9 centimeters is the shortest, and 15 centimeters is the tallest. So I could turn that into a subtraction sentence of 15 centimeters minus 9 centimeters equals 6 centimeters. So that's the difference between the tallest and the shortest bean plant. Are there any measurements outside the main grouping? So here's like our main grouping, right? That's where like most of the plants are all together. I want you to pause the video. Are there any measurements outside the main grouping? And then click play when you're ready to go over it together. All right, friends, what do you think? Yeah, there is, right? This 9-inch or 9-centimeter plant all by himself, right? So why might this one plant not grow the same as the others? Yeah, maybe like the needs that it has weren't met. So maybe it didn't get enough water or had poor sunlight or poor soil. So there's different reasons why this plant might not have grown to the same height as the others. What do you think would happen in 5 more days if we watered and gave extra vitamins to the plants? What do you think? Yeah, they'd grow taller, right? Oh, look how tall that could grow. Crazy. All right, so good job with that one, friends. Let's take a look at another set of data. So in PE class, Mrs. McDougall measured the students' flexibility with the sit and reach test. The table shows how far students were able to reach in centimeters. So look, I'm pretty flexible. Let's see. Here's the data that we collected. You're going to use the data to create a line plot. Make sure to add your labels. Okay, so pause the video. Create your own line plot. Notice where the measurements should start. Do we want to include from 0, 1, 2, all the way to 34? Or what can we do to show a break in our number line? Okay, so pause the video, create your line plot with your labels, and then click play when you're ready for the next step. All right, friends, pause if you need more time. All right, so here is my line plot. First, I'm starting with my number line. Okay, so notice I have a break in my number line, and I can go from 0 all the way to 22, but only because I put in those 2 lines to show that break. Okay, and then we have to go all the way to 34 and include every measurement from 22 to 34, even if those measurements are not included on my chart. So we measured in centimeters, and each X equals 1 student. My title is the sit and reach distance. All right, so let's start including our data. So we have 22 centimeters. Well, there was only 1 student that had 22 centimeters, so we would put 1X. 23 centimeters had 1 student. 25 centimeters had 1 student. Nobody had 24, so that's why I skipped it. 26 centimeters had 2 students. 27 had 3 students. 28 had 4 students. 29 had 3 students. 30 had 3 students. 31 had 1 student. And 34 also had 1 student. No students were measured with having a distance of 32 and 33. So yay, good job for drawing your data for that line plot. So let's use our line plot to answer some questions about the data. How many students were the most flexible? So pause the video, find out how many students were the most flexible, and then click play when you're ready to go over it together. All right, friends, here we go. So this was my longest line on my line plot. So that tells me that it had the most students. So 4 students is my correct answer. All right, for our next question, it says, how many distances were reached by only 1 student? So pause the video and find the answer to that, and then click play when you're ready to go over it together. All right, friends, pause if you need more time. So here we're looking for distances that had only 1 x for 1 student. So here are those. And then I have a total of 5 distances. So 5 distances were reached by only 1 student. How many students can reach farther than 28 centimeters? So pause the video, answer that question, and then click play when you're ready to go over it together. All right, friends, pause if you need more time. So I'm going to put a box around the things that were farther, the distances that were farther than 28 centimeters, which would be here. And then I would count all of the x's in there, which happens to be 8. So 8 students can reach farther than 28 centimeters. Why aren't 24 centimeters, 32, and 33 centimeters listed in the table? I want you to pause the video. I want you to think about that. Why are there no measurements for that? All right, friends, pause the video if you need more time. Otherwise, here we go. So why aren't 24 centimeters, 32, and 33 centimeters listed in the table? Because no students had those flexibility measurements. We still include those measurements on our line plot because if there are no x's shown for that measurement, then someone reading the data would know that there were no students with those flexibility measurements. All right, so awesome job with that one, friends. All right, here's a copy of your problem set if you need it, okay? And boom, you guys did a great job drawing a line plot to represent measurement data and drawing conclusions about the data. So answering those questions, that's awesome. Please head back on over to the module to see what you need to complete for your independent practice. As always, if you have any questions, please let me know. I'd be more than happy to help. And I hope you guys have a great rest of your day. Bye, friends!